So this is the video for the organic review. The test will be a slightly shorter but very similar kind of question deal. Oh, I didn't know there was a. Okay, sorry. Um, we have to. There'll be a couple of name, couple of draw, couple of polarity questions, and then that's about it. Two reaction questions for the esters and the amides, but more or less the exact same structure to it. So let's get started. C5H10. So here we know that there's exactly, so if we have 5 carbons, there's exactly double the hydrogens, and we know that is that is a property of an alkene. If we go back to our thing here, we know that alkenes are Cn and then double the hydrogens, so we can know that's an alkene. And there's 5 carbons, so we have to add the pent. That's this one. C4H10. 4 carbons, so double 4 would be 8 hydrogens. This has more than double, so it's an alkane with 4 carbons, is butane. Okay, identify functional group is an OH, so an alcohol, so an OL ending. How many carbons? 1, 2, 3, 4, 5 carbons, all single bonds, so it's pent. All single bonds, so an, all at the first carbon, so to speak, because, whoops, this is carbon 1, so pentan 1 all is the name of this compound. Again, NH2 is the amine, so the amine ending, 1, 2, 3, 4, 5 carbons with all single bonds, so that's pentan 1 amine. If you do not put the 1 that is acceptable for the purposes of this course, I will still give you the mark. Okay, no functional groups, but in alkene, a double bond is seen over here. So we have to do 1, 2, 3, 4, 5, 6 carbons, so hex. And then the double bond means there's an ENE, an alkene ending, but that's after the second carbon, so hex 2-ene. Here it is important to note to put the functional group ending because it's not at the first carbon, right? Because then it's a completely different molecule, and therefore this is important. I will be deducting marks if you don't put the 2. Well, half mark. Because, for example, this has 1, 2, 3, 4, 5, 6 carbons, so it's also hex. There is a typo here. There should be 2, and this should just be CH. But hex 1-ene, because the double bond is after the first carbon right there. So this is hex 1-ene. Here's a diagram. CH3, CH2, COOH. We know that this is a carboxylic acid, so it has the ending oic acid. How many carbons? 1, 2, 3. All single bonds between the carbons. So it's propan oic acid. We've come to the draw the compounds question. Very similar idea to what we just, or what I just saw, but what we practiced with the practice to organic compounds worksheet. 2-ene, so there's a double bond. I know that by the ene. I know it's after the second carbon in a 5-carbon chain. So it's always like piecing together different kinds of parts to kind of solve a puzzle almost. So 5 carbons, 3, 4, 5. After the second carbon, there's a double bond. That's the ene, and then fill in your hydrogens as necessary. Right? Just count the bonds. If you're confused as to where I got these hydrogens, sorry, you're going to have to look at some previous videos where I go over that in more detail. But essentially it is, you look at the number of bonds that each carbon atom has, and then you fill up the hydrogens to get to 4. So, for example, this carbon had only 1 bond over here to other things, so you needed 3 hydrogens to get to 4. This carbon had 1, 2, 3 bonds, so you needed 1 more hydrogen to get to 4. This carbon also had 1, 2, 3 bonds, so you needed 1 hydrogen to get to 4. This carbon had 1, 2 bonds, so 2 hydrogens to get to 4. This carbon had 1 bond, so 3 hydrogens to get to 4. Hept3-ine, so hept standing for 7 carbon atoms, ine meaning a triple bond, after the third carbon. So 1, 2, 3, triple bond. And now we just, again, add hydrogens as necessary. H3, 2 bonds, so H2, 4 bonds already, 1, 2, 3, 4, so there's no H. 4 bonds also, no H. H2, H2, H3 as needed. Okay. Octane. Here I will accept 2 answers. If you just want to put C8 and you know the formula H2N plus 2 C8 818, I will technically accept this. But if you want to draw it out fully, you would have to draw 8 carbons, 4, 5, 6, 7, 8, and then if it's an octane, there's no functional groups, no double bonds, no triple bonds. You just keep adding H2s, except at the ends where you get H3s. That's an octane. Very straightforward, hopefully. Hexane 2-all. Again, hexane, 6 carbons, all single bonds, 2-all, so an alcohol functional group, OH at the second carbon. Fill in hydrogens. Hexane 2-all. Pentane 3-one, ketone, so double bond O at the third carbon in a 5-carbon chain. 5-carbon chain, the third carbon, there's a double bond O. Fill in the hydrogens. This carbon has 1, 2, 3, 4 bonds, so no hydrogens are required. Heptanal, aldehyde, so C double bond O at the end of a molecule. Hept, 7 carbons at either end. I can put it at this end, so double bond O, which means this has 3 bonds, so 1 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen, 3 hydrogen. Butanoic acid. Butane is, so first oleic acid is the carboxylic acid, so C double bond OOH is the functional group. Butane standing for 4 carbons, 4, C double bond OOH at the end, and then fill in the other hydrogens as required. Oops. Hexane 3-amine. Hexane, 6 carbons. 1, 2, third carbon. Amine is NH2. H3, 2, 3 bonds, so 1 hydrogen. And you fill in the rest of the hydrogen. So this is hexane 3-amine. Benzene, we've reviewed the things if this is looking foreign to you. That was a weird. Toluene. Phenol. 1-chlorobutane. So butane. Then off the first carbon there's a chlorine group. Heptane. So 1, 2, 3, 4, 5, 6, 7. Off the third carbon there's an iodine group. Then fill in your hydrogens. And that's that. Alright, so this is the, continuation. Sorry about that. Okay, methanoic acid and methanol. So methanoic acid is 1 carbon with the oic acid ending, the double bond OOH. Then methanol is the 1 carbon alcohol, like shown. We're going to remove the water. Then we're going to add HC double bond O, OCH3. You start writing from the acid, so methan O8, because that came from the acid. Then methyl, put it before because it came from the alcohol. Butanoic acid, propan 1-amine. Butanoic acid is CC. And then This is propan 1-amine. Remove the water. Our reaction then gives us CH3, CH2, CH2, C double bond O, and H, CH2, CH2, CH3. Again, start writing from the acid, so that was butanamide, and then propyl from the amine part. So propylbutanamide is the name. State which solvent these compounds would be soluble in, CH. So again, this is basically just to see whether you can identify if a compound is polar or nonpolar, or has both the characteristics. So CH4 is nonpolar because it's only carbon-hydrogen bonds, so it'd be hexane. CH3OH, there's some nonpolar, but mainly this is CO bond, which is polar, and an OH bond, which is polar, so this is a polar, will be soluble in water. C9H17OH, this does have a CO bond, so there's also an alcohol, so it has a CO bond and an OH bond. However, you have there's 9 carbons with all these hydrogen bonds. That's basically going to make it look like C, 6, 7, 8, 9, OH. So this little part here is polar, but all of this is nonpolar, so majority of the compound is nonpolar, therefore it will be soluble in hexane. Hexanoic acid, 2, 3, 4, 5, 6, double bond OH. So again, this part is polar, this part is nonpolar. Nonpolar kind of wins out. I mean, but it's not as much as this much, right? Because this was huge. This is not as much because there is a big polar part as well because of the double bond OH. So this is both hexane and water, I would say. Oct3-ine, there is no oxygen, nitrogen, fluorine, none of that. It's just carbon-hydrogen bonds, so that's a non-polar compound soluble in hexane. Hept2-one, this is the compound, it's a ketone. Here you have a bit of polar part here, and here you have non-polar spaces. This will probably be both, I would say hexane first, and then maybe a little bit in water just because of this little polar thing. If you said non-polar hexane, that would be correct. Increasing order of boiling points, again, we just have to follow the order here. Non-polar stuff, so this is non-polar because it has no functional groups added onto it. So this is the lowest boiling point, ethane. Next lowest would be this, which is just a regular polar molecule because it has a CCl bond, but that is still not one of the special ones because this has an OH. So that will be our special case because of hydrogen bonding, and that OH being special will have the highest boiling point. Similar idea here, C3H6, nonpolar. Then you have CH3F, which is a regular polar, no special, because remember this has a CF bond. There are no HF bonds in CH3F, even though they appear next to each other. This is what CH3F looks like. And next we have C4H9NH2, because this is a special hydrogen bond. It has the NH bond. And then we have CH3C double bond OOH, because this has a special H bond, plus it has a polar thing, so it's kind of like double the effect, and therefore it will be the highest boiling point. Alright, so again, make sure you know the answers. If you're still confused as to the reasoning as to how I got some of these, please look at the earlier videos, because the exam will be very much similar to this, except I'll just, instead of, if the question here was Oct3-ine, the question on the test is going to be like Hept3-ine or something. Very similar kind of questions. So, yeah, I will leave you to that. Yeah, study well. Don't procrastinate like I did while making these videos. Good luck. I will see everybody on Monday.